Hello, good afternoon, Star Algebra. Today, your topic is going to be solving systems again, but this time we're going to be using the calculator exclusively. So I'm going to show you with about one or two examples what you're going to do today, and then you're going to model this, and this is going to count as your first quiz grade for my class this 9 weeks. So here's what you're going to do. Let's take example 1. Example 1 gives us two equations. The first one is x minus 4y equals 0. And the second is 3x minus y equals 11. Now, what you want to do first is, in order to use a calculator, you're going to have to get these in standard form. And standard, or actually not standard form, slope-intercept form, or y-intercept form, in other words. The reason is because when you graph graphs in a calculator, if you see here, they all begin with y equals. Because calculators are already standardized to take equations in only in the y equals form. So we got to make both these equations y equals. Unfortunately, this is x and y. So what I have to do is get the y all by itself. So what I'll do first is I'll subtract x from both sides, from here and here. And that now leaves me with negative 4y equals 0 minus x, which is just minus x. Now I divide both sides by negative 4. And I now have y equals 1/4 x. Because there's a 1 here, that's 1 over 4, which is 1/4, and negative divided by negative is a positive, so it becomes a positive 1/4 x. That's the first line. Now I got to take our second line and also solve for y. I have a positive 3x that's in front, so I have to subtract that 3x to get rid of it. When I do that, my line cancels out right here, and I'm left with negative y equals 11 minus 3x. However, we don't graph negative y, so I have to change the sign on everything here to get the positive y. Negative y turns to positive y. Positive 11 will then turn to a negative 11. Minus 3x will turn to plus 3x. So now I have my two lines. I'm going to go ahead and enter those into my calculator. So on my first line, I'm going to enter in 1/4 x. In order to do that, I have to enter 1/4 in as a fraction. So it'll be 1 divided by 4, and then x. Next, I'm going to go to my second line, which is negative 11 plus 3x. Negative 11 plus 3x. Now I'm going to go ahead and go to Zoom Standard. That's your regular 10 by 10 graph. And I'm going to watch the lines appear on my screen ever so slowly. Now, I see they intersect somewhere over here, but I can't tell where. So here's what I'm going to tell you how you're going to do it. There's a couple of ways. We can look at the table first and look to see where x and y have the same value. And I see that right here at 4, they both have a value of 1. So there's my solution. When x is 4, excuse me, let me bring this down a little bit. When x is 4, my y is a positive 1. Another way I can check is I can go ahead and go to, let's see, trace. When I go to trace, I'm going to go right to where I see them intersecting. But unfortunately, the trace function doesn't really do too much of an exact match. It kind of gives you like decimal numbers. So you want something a little better. The best way to do this overall is to go to, I believe it'll be calculate, second and calculate. Because calculate is the blue button right up here, you need to press the second key in order to get to it. Now you're asked for a bunch of options. Option number 1, you can barely see that up here because of the glare. Let me see if I can show this a little better. Says value. Number 2 says 0. 3 says find the min. 4 says find the max. 5 says find the intercept, or the intersection of these two lines. So I want to click on that. And it says, do you think your first line's about right there? I'll say, sure, it's about right here. Second one, somewhere over here. Sure, why not? And then, what do you want to guess? No, I want the exact answer. So keep pressing enter. And it tells us they intersect at 4, 1. I know it's kind of hard to see because of the glare, but there we go, 4, 1. So there's our first solution. Let's try this again now with the next equation. Now we have x minus y equals 1. I'll go ahead and draw two little tables here. I have x minus y equals 1. In order to get y by itself, I'm going to have to first subtract x from both sides. So that leaves me with, see, that cancels out. I have negative y equals 1 minus x. However, we don't graph negative y, we only graph positive y, which means I have to multiply everything times negative 1 to make it the opposite. So negative y will turn to positive y, positive 1 will turn to negative 1, and minus x will turn to plus x. Whoops, there we go. So there's our first equation. Second equation I have was 5 halves x minus 1 equals y. That's already in y equals form, so I can graph it just like that. 5 halves x minus 1. So I'm going to go ahead and graph these two lines. I'll start off by clearing out what I had. I just go ahead and, really simple, just press the clear button over here underneath the arrow keys. Let me zoom out a little bit so we can see a little better. Okay, now let's go ahead and focus really quick. I know there's a glare, so I'll do my best to try to tilt this to kind of avoid it. So my first equation is y equals negative 1 plus x. So I'll go ahead and clear out both, delete both. Okay, so my first one is negative 1 minus x. That's my first line. My second line is 5 half x minus 1. The fractions will have to go in parentheses. The x will go right outside, and then just minus 1. Enter. Now I'll go ahead and go to graph. See if I can get a view where these are going to cross. It looks like they're crossing over here on the y-axis, but just to be sure, I'll go ahead and calculate it. Second, and then calculate. I want to find the intersection, because wherever they intersect is the solution when you have a system of equations. Intersect, enter.